Right. Guys, I don't know what happened. This is my first time doing a live stream session. I'm not too sure what happened there. I got disconnected and I've been struggling for the past 10 minutes or so to come back online. But I think we can continue with question 2 following question 1. So, as you would know by now, that question 2 will really be based on the topic of sequency and series, and usually it will be broken down into three questions where you look at quadratic, sequency, and then you look at the next question that will be a combination of an arithmetic, sequency, and series. Then the last question would be around a combination of a geometric sequence and series. Now, sometimes they can mix all these sequences because they are interrelated. So you must be flexible also in terms of solving them in that sense. Now, when we look at question 2, they say to us here that we are given the quadratic sequence, which is really defined by 0, 5, 14, and it goes on to 779 and also 816. So now let's put this sequence down. So with this question, so we are on question 2 and we are given 0, 5, 14, and we say this continues until it gets to a 779 and also 816. Now, there's a couple of things that we have to look at when we really study this sequencing. One, I'll say this is a sequence when we are told there is a quadratic sequence. That's the first thing. Secondly, I would say that this type of a sequence is a finite sequence. To say that it's a finite sequence simply means that it has the last term, it ends exactly here. Remember, if we were to put the dots here, it means it's continuing. Then it becomes an infinite sequence. So this is a finite sequence. It ends exactly at 860. 860 is really the last term in this sequence. Now, because they said that it's a quadratic sequence, it means that we are going to have the first difference here of 5, because I'm going to say here 5 minus 0. Then I'm going to say 14 minus a 5 to get the second of the first difference, which really this will be a 9. And we then look at the first of the second difference. If you look at the second difference here, we will say then now 9 minus a 5. So if you subtract a 5 from a 9, you should be able to get a 4. And this sequence will continue doing that just like that until we get to really that point. Now, I think, and obviously we know that the second difference of the sequence will be common. It will be a constant second difference. It will be the same. It will be a common second difference in a quadratic sequence. Now, under 2.1.1, they say write down the value of the fourth term, T4, of the sequence. So we are looking really here at, so this is 2.1 and we are at 2.1.1, and then we want to find T4. If you look at here, I have T1, T2, and T3. We want to find T4 here in this sequence. Now, how do we determine that? Now, you would know, studying quadratic sequences, that if we take this number plus this number, we should get that number. So if you say 5 plus a 4, it should give you a 9. And we know that here, if we were to find the difference between 9 and the number that's sitting here, the number that I'll get here, I should get a 4, right? Because remember, we have the second common difference here. The numbers that are sitting here are all the same. Now that means, in the same way where I said 5 plus a 4 to get a 9, I will say here a 4 plus a 9, it should give me a number that's sitting here. And that number should be a 13. 4 plus 4, it should give me a 13. Now, this 13, if you look at it, is a difference between this number that's sitting here and here. So in the same way, if you come here and say 5 plus a 9, you should get the 14. Because remember, to get this 9, we say 14 minus a 5. So if you say 5 plus a 9, you should go back to a 14. Now that we have found this 13, I'm going to say 13 plus a 14, right? And a 13 plus a 14 should give me a number that's sitting here. 13 plus 14, it should give you a 27, right? Because you're having a 14 plus a 13, that's 7, that's 2. So it means the number that will sit here will be a 27, and that is our fourth term. So we're really not doing any calculation here. Even the question said, write down the fourth term. So you just literally write down the fourth term. Now moving along to question 1.1.2, they are saying here that determine an expression for the nth term of this sequence. So here is like we're looking for the general formula. When they say the nth term, we're looking for a formula that can define any term in this sequence. Now, to get that formula, you must remember that we are going to use the fact that the common difference of any quadratic sequence is defined by 2a, the common second difference, meaning the numbers that are sitting here are always defined by 2a. Now, our common difference, we said it's a 4, right? So we said our second common difference here is a 4, and we are writing now the formula 2a. Then when you solve for a here, you should be able to get a 2, because I'm dividing both sides by a 2, so that I have only the a this side, and a 4 divided by 2 is a 2. The second thing that you need to do here to find the value of b is that, because remember here I'm reconstructing this general formula of a quadratic sequence that says Tn, any term in the sequence is given by an squared bn plus c. So I'm just looking for these numbers. Then I would have found my general formula. So I found a, now we're going to b. Now to get b, we say here that the first of the first difference, right, meaning t2 minus t1, is always defined by 3a plus b, always. So I'm saying here that if you take this number minus this number, you get the first of the first difference. So this number here, the first of the first difference is t2 minus t1. It will be always given by 3a plus b. Now the first of the first difference, meaning t2 minus t1 here, we are saying that it's a 5. When you subtract these two, you get a 5. So it means t2 minus t1 is a 5. So I'm going to write a 5 here, and then here I'm going to have a 3, and now we have a 2. I'm going to put this 2 here, right, because we are saying that the a is a 2, and we are looking for a b. We don't have the b. Now when we solve this, we can see that we are going to have a 6 here, a 5, and a b. Now taking the 6 to this side, we are going to have a 5 minus 6, and this would mean that now we're having a b is equals to -1, because 5 minus 6 is -1. Now we have our b here. To then get the c, the last part here, we then say that the first term of the geometric sequence t1 is always given by a plus b plus c. So what I'm saying here is that if you want the first term here, which is a 0, it will always be defined by a plus b plus c. So the first term is a 0, and we know our a is a 2, we know our b is -1. Remember, when you take the negative and put it here, it's going to be a negative here. Positive and negative gives you a negative, and we don't have the c. We are actually trying to find the c. So now I'm having a 0 is equals to, I'm going to have here a 1 plus c, and therefore it means our c is also given by -1. Now when we use our equation Tn is equals to an squared plus bn plus c, you would come to see that we are going to substitute the numbers that we have. Our a is a 2, then we have an squared, we have a 2n squared, and our b we're saying is a -1, so we're just going to have a -n, and our c we're saying is a 1, then it becomes -n. Therefore our general formula, or the nth term of the sequence, will be given by Tn is equals to 2n squared minus n minus 1, and that's how you find the general formula. The next question, 2.1.3, says calculate the number of terms in the sequences. So we want to find how many terms are in the sequences. So what we are actually looking for here is really finding n, the number of terms. How many terms are in the sequence? Now remember, I said this sequence is a finite sequence, meaning it ends exactly here. This is the last term, so this is the nth term. This is the Tn, right? So it means here we know that Tn is equals to 860 because it ends there, really. So that means on my formula, I will then have 860 is equals to 2n squared minus n minus 1. And then when it's sitting like this, so I've just substituted the Tn here, and I've kept everything like that so that I can look for my n. Now when it's sitting like this, we are going to put everything on one side so that we have the standard form of a quadratic sequence. So I'm going to have here a 2n squared minus n. Here I'm going to have minus 1 minus 860, because when this comes this side, I'm going to have a minus 860. So this means I'm going to have here a minus 861, and this will be equals to 0 because I'll be left with nothing this side. Because this is a big number, you might not want to attempt looking for factors. It could take you a long time to actually find factors. I would advise here that you can use the quadratic formula. However, in my case, I just happen to know my factors that I'm going to have here as my factors. The factors that will be sitting like a 2n and n. Because I have a 2 here, I'm going to have 41 and 20. And my 20 has to be negative, and I can have a positive here. So you can use really a quadratic formula at this stage. You don't have to worry about finding factors if you really can't find them. And at this stage, it means n is going to be equal to 41 over the 2, or n is going to be equals to 20. Now remember that when we're dealing with sequences, n is an element of real numbers. In other words, it can only be the counting numbers 1, 2, 3, 4, 5, and so on. So what we're saying here, we're saying that if you count terms, you count them using real numbers. You're going to have term 1, term 2, term 3, term 4, and so on. So this number here, n, it is allowed to be only real numbers. So that means by default, if I start having a number that looks like this, I have to reject that number. N should not be equal to this number. This is a very important thing for you to do, because if you leave this with an equal sign, you are going to lose marks here. So you have to tell us that this is not a solution, it's not an answer to this. But 20 looks quite reasonable. So this means here, when we get to this point, this will be T20. This is the 20th term, the 860. So that is the last term in our sequence. It's going to be that number. Now we are going to move along to the next question, which is 2.2. And it says to us that determine the sum of the whole numbers between 100 and 1000, which are divisible by 11. So there's a lot of things that are happening here. So what we want to find here, or what we are required to actually determine under 2.2, is to actually find the sum, right? We have to find the sum. But the tricky thing is that we don't have the number of terms as well, because we don't know what term we are at. So that's one thing to know. But the other thing here that we have is that they say when we're looking for the sum of whole numbers that are between a 1,000, 100 and a 1,000. But also you can divide them by 11. When we say that divisible, it simply means that when you divide by 11, there is no remainder. 11 will just go in those numbers and leave no remainder. Now, if you quickly play with your calculator, you'll see that if you say 100, if you say 100 divided by 11, it's actually not divisible. It has a remainder. You see, you get the 9.09. So 100 cannot be. Remember, we are looking for let me put this, we are looking for Tn to be between a 1,000 and 100. It has to be between these two numbers, right? And it is not allowed to be any of these numbers, because it's less. It's not less or equal to. So we don't have less or equal to here. So it lies in between. So and beside, our 100 here is not divisible. But now the tricky for you to find the first term here, you will say 100 plus 11. It then gives you if you say 100 plus a 10, it gives you 100 plus a 10, it gives you 110. Now if you say 110 divide by 11, 110 divided by 11, do you see now it is divisible? 11 goes exactly 10 times inside our number. So it means our first term here, and 110 is between, 110 lies in between, it's bigger than 100, right? So that will be our first term, 110. And because we want these numbers to really be divisible by 11, it will be smart for us to actually have them increasing by 11. In other words, if I increase this by 11, I say, to find the next term, I say 110 plus 11, it then gives me 121. I have 121 here, 121. Well, the reason is that if you increase them by 11, you'll find that when you divide them by the 11, you will then get them to be divisible. So what I mean is that if I say 121 divided by 11, it then becomes divisible. Do you see that it goes exactly 11 times? So that is the second condition that we were given, to say 11 must be divisible to those terms. So it means I will increase this again by 11, right? And if you then add 11 here, you should get 132, right? Because if you say 121 plus 11, it gives you 132. Now, if you say 132 divided by 11, it goes exactly 12 times. I think you can see the pattern here. The first one goes 10 times, the second one goes 11 times, the third one goes 12 times, the following one will be divided 13 times. So this means, you can continue increasing this again by 11 to get the next term, and you'll continue doing that until you get to a point where, remember, we have 1,000 there at the end, and you're dividing it by 11, it doesn't go. So it means we have to find a number here. Our last number should be less than 1,000, should be a number that is less than 1,000. Now, if you try to say, in the same way how we began this, if you say 1,000 minus a 10, if you say 1,000 minus a 10, you get 990, right? So here it means we are going to have 990. And then if you then come and say 990 divide by 11, okay, 990 divide by 11, it then goes exactly 90 times. So it is divisible, and you can see that 990 is actually really less than 1,000. So it's in between, 100 to a 1,000. So that's how you really construct your terms. And there is no any other term that will allow 11 to divide in it apart from 990. So that's how you can really reconstruct this sequencing. Now, when you are at this stage, we then have our sequence. In fact, this is not a sequence, it's a series, because we want the sum of a series. So that means here, it will be wise actually to write here the following, to put a positive sign to show that I'm adding, these terms in a sequence, in a series. They're a series, right? So we're adding these terms. Now, if you've been following, you would see that this actually becomes an arithmetic series, in that it has the common difference. It has the constant common difference. In other words, our D here is equals to 11, and our term 1 is an A and is equals to 110. You should be able to see that. And before we can find the sum, we need to know how many terms are in this sequence, right? We have to find the value of n. We have to really know that, so that we can find the sum, because the question wants us to calculate the sum. Now, because this is an arithmetic sequence, I will use the formula for an arithmetic sequence to say Tn is equals to A plus n minus 1 times D. Now, this formula is there in the formula sheet. You can always go take it there and use it. Now, you will find that our last term, our nth term here, is actually the 990, right? So our Tn is the 990, because that's where our sequence will end. And this will give me the first term of 110. We are adding here n minus 1 because we're looking for n, and then our common difference is indeed 11. Now I'm going to take this 110 to this side, so that I'm saying here 990 minus 110. I hope you can see that this will be 880, because I'm just subtracting the ones here. So I'm left with 880, and this side I'm going to have this 11 multiplying here and multiplying there as well, so that now I have 11n, and I also have negative 11. I'm going to then take this number and put it this side, so that I have like terms on one side. So if I say 880 minus 11, right, that should give me 11n should be equal to 891. That should be 891. I hope I'm correct there. Now, to find n, we then divide both sides by 11, right? This one I'll need the help of a calculator. I'll then say 891 divided by 11. Then it gives me 81. So here I then have 81. And this answer actually makes sense. It's a very nice answer, because remember, n has to be an element of real numbers. Always your n has to be the counting numbers, right? Because we're counting the number of terms here. Now that we have our n, and we know that this is an arithmetic series, we are then going to use the formula of the sum of a series, which is given by Sn is equals to n over 2. Then I'm going to have a square bracket n minus, well, no, not minus, n plus the last term. Now I'm using this formula because I know the last term. I know that my sequence ends exactly here at 990, right? It is not an infinite series. It doesn't continue. So I'm using this formula to say this will be the last term. And again, this formula is there in your formula sheet. Now, from here, this question becomes a simple substitution problem, where we're saying we are now looking for the sum of 81 terms, yeah, because we know that we have 81 terms in this series, which will then give me 81 over 2, and here I'm going to have 81, just to write that properly, 81 plus the last term is 990. All right, the last term is 990. Then I can punch the whole thing in a calculator to find my answer. So here we're going to have 81 over 2, 81 plus 990. And this says to me that I'm having here okay, my formula is wrong. I see now that my formula is wrong here. I've done a mistake. So guys, as I was saying, you can use the formula sheet. So here I've written n. It's actually not n. You should get an a here, right? So on our formula, this is the first term a. So if I put an a here, it means I'm going to put the first term, which is 110. So the first term here is 110. So this is not n, it's 110. I think I was confusing this formula with this one here. Can I have a space so that I can write this one? Yeah, I think I was confusing this formula or mixing it with this one here, n over 2a, because I know there's an a and n there, plus n minus 1 times d. So even if you use this formula, it will work. Just that now, here it's easier because we have the last term and it becomes easy and simple. So this could be a bit long, but even if you use it, you should be able to get the same answer. So now here it means I have the 110 and my answer is 44,550. So the sum of 81 times is 44,550. So this is the sum of 81 terms. And that's how you will answer that question. I hope it made sense to you. Yeah, there's a bit of tricky things that you need to do there. Figuring out the numbers that are divisible by 11 and they lie between 100 and 1000. I think that's a tricky one. But yeah, maybe I have helped and clarified how you can tackle a question like that. I'll move right straight to question 3 because I see that we are running out of time. I think after question 3, I will just stop here because I scheduled this for until 9 o'clock. So we'll just do the next question, which looks at again sequence and series. And I mean, if we have already done quadratic and arithmetic, it means this one could probably be a question that looks at geometric sequence and series. Now they say here under 3.1 that we are given the geometric sequencing, which is defined by those numbers there. So the first term in this sequence is 8 x minus 2 squared, and you also have 4x minus 2 cubed, 4x minus 2 cubed, and I think we have a 2x minus 2, and this is to the power 4. Interesting. And this sequence continues like that. It's an infinite sequence that goes on without stopping. And there's a condition to this. They say here to us that our x should never be equal to 2. Can any of you guys guess why the x should not be 2 in this case? Well, if you look at this sequence, we have the same term here. We have the same binomial. By saying a term, I mean a binomial. X minus 2 happening here. Now, if our x becomes 2, it then means this will be a 0 here, right? So this will be a 0, a 0, a 0. Then we'll end up having a sequence that is only made up of terms that are 0, 0, 0. And I mean, a sequence like that is not really interesting. There's nothing much you can do with such a sequence. So if x is any number but not 2, we can then have an interesting sequence. We can have, different sequences that come out of this. We are told that this thing is a geometric sequence. So it must have a common ratio, right? It must have a common ratio. Now, the question then says to us 3.1.1 to determine the value or values of x where the sequence converges, right? Very important question that you will always, in your exam get, and you need to really understand what it means. Now, for a sequence that converges, when you say a sequence converges or a series converges, it means that when you add the terms, they actually approach a certain number, you know. So for instance, if you were to have any sequence and you add the terms of that sequence, and then those terms, they go closer to a certain number. Let's say when you add them, when you add Sn, they go towards a number 2. When you add the 2, they approach a number 2. So they're not equal to 2, but actually they approach 2. We say it converges. But there are those sequences that when you add the numbers, the terms, when you add them, you find that actually the sum is getting bigger, is getting larger. It doesn't go to a specific number like a 2 or any other number you can think of. It actually becomes larger. So you'll find that when you add term 1 and term 2, maybe you get a 3. But when you add term 1, term 2, and term 3, you get a 10. When you add term 1, term 2, term 3, term 4, term... So the more you add terms, you get that it's, you know, it's getting bigger and bigger. Then we say it is diverging. It's getting bigger, it's diverging, it's opening up. That's what it means. Now, sequences that diverge, they actually diverge under the condition that your common ratio should lie between -1 and 1. So if your common ratio is between 1 and 1, your sequence will converge. In other words, it will approach a certain number as you add the terms. You know, maybe the number can be 2 or whatever number. But as you add the terms, it will go towards 1. But that only happens when our R is between -1 and 1. So this means here we have to find first our R. So to find the R, I'm going to say R is equals to term 2 divided by term 1. We know that for a geometric sequence. And this would mean now that if I take term 2, this one here, I'm going to have a 4, x minus 2 to the power 3, and I'm going to divide by an 8, x minus 2, and then we're going to have a 2 squared there. Now, you would see here that 4 into 4, it goes once. And 4 into 8, it actually goes twice. And these two, they're exactly the same here, but they only have different powers here. So this means this one will cancel out completely. You know, I'm only going to be left with 1. But here I'm going to cancel 2 of them so that I'm left with 1. Because remember, this is like I'm having this 3 times here. 3 times, and here I'm only having it once. So I'm having it twice, sorry. I'm having it twice. So these 2 would cancel. I'm only going to be left with 1. That's what I'm saying there. You're going to have 1. So this in a simplified form, I would say, or would put it in such a way that I say my R is then equals to x minus 1 minus 2, sorry, because there's only one of it, and I still have a 2 here. You see, we have a 2 here. So that is my R, common ratio. Now I'm going to take this common ratio and put it here in the middle, right, so that I can find the values of x. Remember, we're looking for the values of x, or value of x. Well, in this case, it will be values because it won't be one value, where we will be able to get the R that is between -1 and 1. So this means here I'm going to have a -1 is less than x minus 2 over 2 is less than 1. Then you see now everything is in terms of x. That means I can find the values of x. I'll solve this as an inequality that will give me the values of x that are between, you know, 2 intervals in this case. Now here we're going to start first by cross multiplying by 2 this side and cross multiplying by 2 this side, because what you do on the left, you do on the right. So -1 times a 2 is going to be a -2. I'm going to have an x minus 2 here, and then 1 times a 2 is going to be a 2. Now I'm going to transpose. I'll take the -2 this side and also this side. Remember, what you do on the left, you do on the right. So here we are going to have -2 plus a 2, right? So -2 plus a 2, this will give me 0 this side. I'm going to have a 0 is less than x, and then this side we are going to have a 2 plus a 2. You know, when it comes this side, it's going to be plus a 2. A 2 plus a 2 is a 4, so this will be less than 4. So this therefore means that the value of x should be between 0 and 4, because when it's between 0 and 4, we are going to get the R, the value of R, that's between -1 and 1, and this series will converge because this is the condition for convergence of a sequence. Yeah, I hope this becomes a good refresher, or you can say revision, of how you do these questions. Now, the next question says to us here that we determine the sum to infinity. Again, this is a popular question that you are most likely going to get. It's always in the exams, where they require you to find the sum to infinity of the series. And then they say here, if x is equals to 2.5. So we are doing 3.1.2, and then we're saying x is equals to 2.5. And we want to find where this series converges. Now, look, to do this question, one of the easiest ways, I think there are many ways in which you can do it, is that you can take your sequence the way it was here at the top, this one here, and you put the value of x here, and express it in numbers, so that when it's in numbers, you are now able to use the formula of the sum to infinity to then calculate the sum to infinity. Now here I'm going to put 2.5 because my x was 2.5 there. I'm having a 2 and this is a squared. The next term will be a 4, 2.5 again, minus 2, and this is a squared. Then we are also going to have 2.5, so this was a 2, 2.5, 2.5. Then we're having a negative 2 to the power 4, and this will continue doing like that. Then here we can use a calculator. The first one is 8, 2.5 minus 2, and we're saying this is a square. And it gives me a 2 here, so it means the first term is a 2. The second one, we are going to remove the 8 and then have a 4 here. And this is to the power 3, right? Yes, this is to the power 3. So here I'm having to the power 3, not a 2. Not a 2. So this is to the power 3. So it means I'm going to remove this. So that is a 3. And this gives me 1 over 2. My next term is 1 over 2. And I'm having now here a 2 and then a 4 here. So that's a 4. And let's see. So we're having a 2. No, we're having a 2 here in front, not a 4. A 2. And then this gives me 1 over 8. So this is 1 over 8, and it continues like that. So now it is in numbers. Now, the first term here, we're saying it's a and it's a 2. And our common ratio would be what? 1 over 2 divided by a 2, because it will be the second term divided by the first term, right? And this should give me, if you do this fraction, you can say 2 times 1 over 2. This is 1 over 4. You can use your calculator. Now, to find the sum to infinity, we are going to use the formula that says S to infinity is A over 1 minus R. Again, if you don't know this formula, just check it on the formula sheet. Now, we're going to substitute here. Our first term we're saying is a 2, and here I'm having 1 minus 1 over 4, right? Because that is my common difference. Then now, we are going to put this on a calculator. 1 over 4, and this says we have 8 over 3. So this means the sum to infinity is going to be 8 over 3. And as you would know that, this is an improper fraction. So, usually it's advisable to leave your answer as a mixed fraction. You don't have to have an improper fraction. So your numerator should not be bigger than the denominator. So you must, if you have a small number here, if we had 3 over 8, you'd leave it like this. But if you have a bigger numerator, you must write it as a mixed fraction. And to do that, you're really going to say how many times does 3 go to 8. So 3 goes twice, because we have 3, 6, right? Then we stop there, and the remainder will be a 2. Because from 6 to 8, you only left with 2. So the remainder is 2, and we then take this number here, that is the denominator, and put it at the bottom here. So that's how you leave it as a mixed fraction. Or you can do it with a calculator. The calculator can also give you the mixed fraction if you like. Now, what does the this answer mean? What does it mean to say the sum to infinity is equals to 8 over 3 or 2 over 3? It means that as we add the terms, I keep on making this mistake here. As we are adding the terms here, right? As you continue adding the terms in this series, you continue adding them like that, you'll find that these terms, they add up. They're actually going closer and closer to 8 over 3. They're approaching 8 over 3. So this does not mean these terms, they add up to 8 over 3. It means that they are going closer and closer to 8 over 3. It's like it's a limit. If you know calculus, because right now you have done calculus, it's a limit. The more we add terms in this sequence, the more we approach 8 over 3. That's what it really means. Now we can move to the next question, which is 3.2. And in 3.2, we are given a sigma notation here, or a series that says we have, let's see. So I'm doing 3, 2, and then we are having the summation, the sigma of, so the sigma of 3 minus 2 to the power k minus 2. And we are beginning at k is equals to 2, no, it's equals to 3. So k is equals to 3 to 12. We are ending at term 12. Now, I think you just to revise sigma notation, you should know this, that we are saying here we are adding terms of this series. This will represent the series. This is like Tn here. It represents the general formula of a sequence or a series. So here we are saying we are adding the terms. So this symbol here means summation, the sum. We are adding the terms of this sequence or series, and we begin that when k is 3 and we are ending at 12. So that means I'm going to start first by putting a 3 here. This means I'm going to start first by putting a 3 here. If I put a 3 here in terms of k, I get the first term. Then the next term would be a 4, because k, remember, is an element of natural numbers. If you put a 4, you get the next term. If you put a 5, and then you will end at term 12. That's what it really means here. Now, one thing that I also want to emphasize is that when you look at this guy here, he really looks like n is equals to n minus 1. So this is a geometric formula. So, by experience, I know that when you see this type of a form or this type of a formula, this should be a geometric series, right? But we'll see when we test it out. And in fact, I can start expanding this to just get the first 3 terms. So to do that, I'm going to say here that 3 minus 2 to the power 3 minus 2, right? So all I've done here is that I'm taking these 3 and substituting it here to get the first term, right? And our first term comes out really to be, it comes out to be a negative 6. And the next term, I'm going to put a 4, because after 3 comes a 4. So I'm just going to put a 4 there. Then it means the next term that I'm adding is a 12. And then I'm going to put a 5, because after 4 comes a 5. Then it means the next term that I'm adding here is a negative 24. So if you add a negative 24 here, you'll end up having a negative 24. And this will continue until we get to 12. So that means here we're going to put a 12, and we get 3072. So that means the last term, I don't have space here, the last term will be 3072. That's the last term that we're going to have in this series. Now, I think we can answer questions here. 3.2.1 says how many terms are in this series? Right, how many terms? 3.2.1, we're looking for n. How many terms? So if I were to count these terms here, term 1, term 2, term 3, until this number here, 12, how many terms will I have? Now, you have to be careful with these questions. The answer is not 12, because you can see here we didn't start at 1, we started at 3. So there's a formula that says to find the number of terms is always given by the upper bound, meaning the number here at the top, minus the lower bound, and we add 1. So I'm going to call this here a J, right? Just so I can create this formula and you are able to memorize it and know it. So you will say here J, the upper bound, the number at the top, minus the lower bound, K. So you find the difference between these two numbers. They'll give you a gap. They'll give you a gap between these terms to say, how much gap is there. But also we need to add 1 in this formula, right? I'm not going to explain at this stage how this formula came about because we're just doing revision. But if you go to a playlist that I have on my YouTube channel where I do lessons in sequence and series, I explain exactly how this formula comes about. Why do we need to add a 1 as well? So in the interest of saving time, it means now I'm going to substitute the 12 and the 3, and we add a 1. And you can see that here I'm going to have 12 minus a 3, that should be a 9. And if you say 9 plus 1, it should give you a 10. So it means in this sequence, we actually have exactly 10 terms, in this series that make up this series. And that is your answer N. 1 mark for free there. Then we're going to 3.2.2. This then say calculate the sum of the series. So calculate the sum of the series. You would notice that I said this series, so we're looking for the sum of the series. So it means we're looking for the sum of the first 10 terms, because remember, we know that we have 10 terms in this series. Remember I said this series is a geometric series. How do I know that? I see this form here. I see that we have an A, and then we have a combination of R coming up there. But you can always, check it. You can come and say my first term here is an A and is equals to a -6, right? And check if we have a common ratio or not. So what I'm saying is that if you do a question like this, don't go by looking common differences. Start with a common ratio. If you don't get a common ratio, you can then go look at the common difference. Because, there's a great suspicion that this is going to be a geometric series. So here we're going to have a 12, which is the second term, divide by -6, and then I get a -2. Do you see that -2? Here it is the R here, right? I get a -2. Let's confirm that if I take the third term, which is -24, then I divide by 12. Do you see that I still get a -2? And you can continue doing others just to check and be sure. But already, if you have experience and have been practicing, you should see that this is my R, this is my A, and this form is a geometric form, as a geometric sequence or series. Now at this stage, we are then going to now use our formula that says Sn is equals to A 1 minus R to the power N all over 1 minus R. So this is a formula for the geometric series to find the sum of the geometric series. And we are saying here that we're looking for the sum of the first 10 terms. Then our A is a 6. 1 minus our R, we said, is a -2. So I'm going to put a bracket here. So this is going to be a square bracket because I have other brackets inside there. So this is going to be in bracket 2, close bracket, and then the end here is a 10, and I'm going to close my bracket. I want to stop here a bit to give you an advice. Don't do a mistake of writing positive here, because remember, this 2 here has a power. It goes with the 10. You have to firstly find this power, then look at that negative outside. So very, very important. Don't do that mistake, because if you write a positive here, you will get the completely wrong answer. This is a power here. There's a 10 here. So you have to firstly find this power. Or at least when you put brackets, the calculator will then help you to find those powers, at that power there. But here then I'm going to say plus 2, because really if I put a -2 here, if I say 1 -2, I get a plus. You see here, there's no power. The power is 1. I can just simply write that positive. It's not the same as this one. Now at this stage, this question becomes very, very, very boring, because we are going to use a calculator, aren't we? So this is going to be a 10. I just want to close my bracket there, and we're having 1 plus a 2. And this says that the sum of the first 10 terms will be 2046. So this says here that the sum of the first 10 terms will be 2046. This is how you will do that last question. Guys, I have to stop here because that's the only time I have for today. I had scheduled this to be until 9 with the objective of doing the whole question paper. But again, we experienced some glitches when it came to the live stream. As I said, this was my first time doing a live stream. I got disconnected and wasted time trying to get back online. I think with what I've covered so far, doing question 1 up to 3, at least I have assisted you with revision for tomorrow exam for those that are writing tomorrow. And I would love to say all the best for your exams, for your preliminary exams. Stay tuned during the weekend. I'll be doing live stream sessions again for paper 2, and we'll try to cover the whole of paper 2 during the weekend time. All the best and good night.